Every model in this whole series came with knobs that we just set by hand, the K in K nearest neighbors, the C in the SVM, the max depth in the tree, the learning rate in boosting, and honestly, we were guessing. Hyperparameter tuning is how we stop guessing and let the computer systematically search for the best settings, with each one scored honestly using cross-validation. First, a key distinction. Parameters are what the model learns on its own, the weights, the split points, the centroids. Hyperparameters are the dials you set before training even begins, and the model simply cannot learn them for you. They shape how the learning itself happens. The naive approach is to twiddle them by hand. Try C equals 1. Try 10, maybe a deeper tree, and just eyeball the score. It's slow, it's unsystematic, and it's dangerously easy to fool yourself by quietly tuning against your test set. We need something far more disciplined. Grid search is that disciplined version. You lay out a grid of values to try for each hyperparameter. The search then trains a model for every single combination on that grid, cross-validates each one, and keeps the combination with the best average score exhaustive and completely fair. But there is a cost. The grid explodes combinatorially, 3 settings here, 4 there, 5 more over there, and suddenly you're training hundreds of models. When the grid gets huge, randomized search is smarter. Instead of trying everything, it samples random combinations and usually finds something nearly as good for a fraction of the effort. And here's the one rule you must never break. All of this searching happens using cross-validation. On the training data alone, your test set stays sealed in a vault until the very end. If you tune against the test set, your final number is pure fiction. You've just memorized the exam. Grid Search CV wraps the entire dance into a single object. You hand it a model and a parameter grid. It runs the full cross-validated search and then automatically refits the best configuration on all of your training data. Afterward, best params tells you exactly which settings won, and best score tells you how well they did. The pieces are a model, a param grid dictionary, grid search CV with a CV setting, then fit, and finally reading off best params and best score. It's a little longer, so 2 pages. Let's write it. Here's the program, 2 pages, every line visible. It takes our SVM from a few episodes back and instead of guessing its settings, searches for the best ones automatically. Let's read it. The imports: make classification for data, the SVC we want to tune, grid search CV to do the searching, and the usual train test split and accuracy score. We make a data set and crucially split off a test set right away, and we promise not to touch it until the very end. All the tuning will happen on the training portion only. Now the grid. It's just a dictionary. A list of values to try for C, a list for gamma, and the RBF kernel. 3 C's times 3 gammas is 9 combinations, and each will be cross-validated 5 times. That's page 1. On page 2, the search itself. Grid search CV handed a fresh SVC or grid and CV equals 5. One object that will train and score 45 little models for us, completely automatically. We call fit on the training data only. Behind that one line, it grinds through every combination, cross-validating each, and quietly remembers the winner. Then it refits that best configuration on all the training data, ready to use. Now we rate the results. Best params shows the winning settings it discovered, and best score shows their cross-validated accuracy. No more guessing, the data chose. And only now at the very end do we unlock the test set, scoring the tuned model on data it has never seen for our one honest final number. And that's hyperparameter tuning. Next time we bring the whole series home, combining many models into one with ensembles and stacking.